We're going to look at how we use gases in equations now. So we're just going to be extending the ideas that we've covered so far. So we're going to be combining what we know about dealing with gases in terms of moles and how we work out reacting masses in equations. So just a little reminder, these are the equations that we could be using. So again, it's just two equations, but each equation has been rearranged. Those are the equations you really do need to be familiar with. So let's crack on with some examples. So here's our first example, and we are looking at iron reacting with steam. And the question would like us to work out the volume of hydrogen. RTP means room temperature and pressure. How much hydrogen are we going to be producing when we react 100 grams of iron? We're going to use exactly the same procedure as before when dealing with reactions. The first thing we're going to work out is how many moles of iron we have. And iron, you see, we've got as a solid there. So we're going to use mass over molar mass, and that gives us 1.79 moles. Now it's time to look at the equation, and you will notice, I'm sure, that for every 3 moles of iron, I produce 4 moles of hydrogen. So in order to work out the moles of hydrogen that I'm going to produce, I need to divide my moles of iron by the number in front, which is 3, and times that by the number in front of the product I'm going to, which is 4. And I do that, I get 2.39 moles. The final little step is now going to find my volume of hydrogen. So I can do that by moles times 24,000. So that's going to be 2.39 times 24,000, which gives me 57,348 centimeters cubed. Now you'll notice that we've only been given 3 significant figures for our mass of iron, which is 100 grams. So we should really only use 3 significant figures in our answer, otherwise we're being far too precise. So we can say our answer is 57,300 centimeters cubed to 3 significant figures. So you may wish to give question 2 a go by yourself if you are confident with how we completed question 1. If not, carry on and we will go through it now. So what we need to do first? Well, we've been given 1,000 grams of butene, so we need to find the moles of butene that we have, and that's going to be our mass divided by our molar mass, which is 1,000. Molar mass of butene is 56, and that gives us 17.86 moles. Then we look at our ratio, and the ratio we are interested in is between butene and oxygen. And you can see from going to butene to oxygen, it's a 1:6 ratio. For every 1 mole of butene, I need 6 moles of O2. So I need to times my 17.86 by 6 to give me 107 moles of oxygen is required. And now I need to find my volume of oxygen, which is going to be my moles times 24,000. So 107 times 24,000, which gives me quite a large number, 2.5 million centimeters cubed. So if we take that to 3 significant figures, it's 2.57 million centimeters cubed. So this example is slightly different. So they've given us now a volume of methane, and they would like us to find the volume of oxygen required to combust with it, and the volume of carbon dioxide produced. And they've told us again that this is at room temperature and pressure. Because we know that the volume of a gas is proportional to the number of moles I have if we keep temperature and pressure the same. If I've got 1,000 centimeters cubed of methane, I can see from the equation for every 1 mole of methane, I need 2 moles of oxygen. So if I have 1,000 centimeters cubed, I need double the volume of oxygen to combust it. So I am going to need 2,000 centimeters cubed. And in terms of the volume of carbon dioxide produced, well, you can see the ratio between methane and now carbon dioxide is 1:1 reaction, 1:1 ratio. So therefore, I am going to produce 1,000 centimeters cubed of carbon dioxide. So if you felt confident with that example, have a go at B, where you've got 20 centimeters cubed of butene. And again, you need to find oxygen, the volume of oxygen, and the volume of carbon dioxide produced. So let's have a go and go through that one. We have got 20 centimeters cubed of butene. I have now got the ratio of 1 to 6 between butene and oxygen. So the volume of oxygen I require is now going to be 6 times 20 or 120 centimeters cubed. And the ratio between butene and carbon dioxide is 1 to 4. So I'm going to produce 80 centimeters cubed of carbon dioxide. So here's a slightly more challenging one for you to get your teeth into. So please feel free to have a go at this before we go through the answers by just pausing now. If not, we will go through it step by step. So we now have 100 centimeters cubed of methane, and it is being reacted with 500 centimeters cubed of oxygen. So we know from our previous examples that I will need double the volume of oxygen to methane because it's a 1 to 2 ratio. So I will require 200 centimeters cubed of oxygen to combust with 100 centimeters cubed of methane. In terms of the volume of carbon dioxide I produce, well, methane to carbon dioxide is a 1 to 1 ratio. So if I have 100 centimeters cubed of methane, I will produce 100 centimeters cubed of carbon dioxide. So the only other thing we need to consider is how much oxygen is therefore left over. They told us I started with 500 centimeters cubed. I've used 200 centimeters cubed of it, so therefore I'm going to be left with 300 centimeters cubed of unreacted oxygen as well. So these questions can be downloaded from the website as usual, and along with the answers. So hopefully you found them useful. Again, with all of these mole questions, just keep going with the practice, and it will all come together eventually. Just remember those equations because they are essential, and more will be coming up when we start thinking about solutions in a future video.